CLR or Common Language Runtime is a very important part of whole .NET framework, and its utter importance is not seen by most of us as it works behind the scenes. This beginner series of my articles will help you to know what actually CLR is in simple terms and what are its basic features. In earlier days of programming, there was no concept of managed code. There was only unmanaged code, which means that all the things should be handled by the operating system. The programming languages compiled the programs written in them to the native code specific to the architecture of the CPU. There are many disadvantages of such an approach, which we will see one by one in this tutorial. So first of all, what is CLR? Actually speaking, it can be considered as a small processing unit of its own, which when given an intermediate language code can produce a native code to be run on that CPU. CLR consists of various parts in which each is a topic of research and discussion and requires an in-depth analysis. For example, garbage collector is a part of CLR. It itself is a big area. So the process in which our programs get executed is, first of all, we have a code in a language. It can be VB, C# or C++. Now we compile this code using the respective compiler for that language. After this first compilation, we receive a IL, or we can also say Microsoft Intermediate Language, MSIL. Now this IL code acts as input to the CLR, and it's just in time compiler chooses the right model to be executed for compilation for that CPU type. So now the JIT decides according to the CPU type and architecture which mode of compilation it should follow. Now after this decision, JIT actually compiles and produces the native code which can run on the CPU. The CLR can be considered as a sandbox environment from which no code can execute outside its given bounds. That is, the code execution is confined, and this is a major advance over the earlier model of program execution. So now you can say that .NET can only execute the managed code and there is no need for unmanaged code, but this is not true. There are some special cases where unmanaged code is the best thing till today. Example, device drivers are real-time applications where performance is a bottleneck, although there are algorithms which will be implemented in future CLR for support of real-time applications. But .NET Framework also provides few ways to write unmanaged code, which will not use facilities of CLR and execute in an old-fashioned way. That is, as I told, GC, garbage collector, is one of the part of CLR. If you write unmanaged code, GC, we may not utilize full facilities given by GC. Okay, let's see. Both C++ and C# has ways to execute this unmanaged code. When the code is first compiled to an IL, we get an exe or a DLL file. This is what we call an assembly. Once you ask this assembly to be executed, it is loaded into an application domain or app domain of the CLR. App domain of CLR is the region in which a process is running and each assembly can get executed without creating a new process side by side with other assemblies without hampering or affecting their execution. Creating separate processes for execution was a performance-intensive task which earlier programming languages used to do, but with CLR this performance lapse is reduced. The other benefit is that this code is compiled only once by the JIT compiler. The other benefit is that this code is compiled only once by the JIT, and after that it can be run utilizing full power of the CPU. So the $1,000,000 question is when ultimately the native code is getting generated, which is also being generated by other languages. What's the difference between this native code and the one generated by CLR? So the difference is that CLR places some information with this native code which tells this native code to follow the execution model and remain in bounds confined by the CLR. Earlier, unmanaged applications never thought of maximizing the overall throughput. They always used to maximize individual applications' throughput. But managed code always tries to maximize the overall throughput rather than constraining a single process. Hope you enjoyed this episode. We shall meet again in next episode. Thank you so much.